right, same three equations as before, but now we're focusing on the x-intercept. So the x-intercept is when y is equal to 0, and our focus is going to be once factored, we're going to set the numerator equal to 0. So we replace the y with a 0. We say 0 equals x minus 4 over 2x squared minus 8x. We factor it. We cancel what we can, and we're left with 1 over 2x. Here is where we set the numerator to 0. In this situation, we know 1 doesn't equal 0, so this one does not have an x-intercept. All right, let's take a look at number 2. Now, for number 2, we already know from doing this earlier, there's nothing you can cancel with the denominator. So it's already factored in terms of with the denominator. So now we take our numerator and we set it equal to 0. And we factor it. All right, so let's see. We can get 3x. We can get 2x. I want to multiply to a negative 3, add to a 7. So if I do plus 3 here and minus 1, does that work? Let's see. We get 9x. Yeah, that will work. So then each individual one you set equal to 0. So we know here x will equal 1/3. So here is one x-intercept. In our other one, we get 2x plus 3 equals 0. So x will equal negative 3/2. So we know in this equation, it will cross the x-axis at least twice. Well, not at least twice. It will cross the x-axis twice. Not at least. Definitely only two times. All right. And let's focus on the last one. So in the last one, there's nothing that can factor. So we want to know, when does x squared plus 5 equal 0? We subtract 5 to get x squared equals negative 5. So that would mean that x would have to equal the square root of a negative number, which we know we can't do. So just like the first example, there is no x-intercept for this problem.